so this is going to be objective 42, and I'm going to use it in this format. I hope that's okay because I need to be able to pop up my calculator because we're going to do this in our calculators. So we are going to write a function rule given a table. We're going to try to cover 3 things today on this video. We're going to cover writing a function rule given a table. I'm also going to try to cover with you cube roots, and if we have time, we're going to take a look at box and whiskers. If not, we'll cover the box and whiskers on Monday. So we'll see how much we can get done. All right. Example 1. Normally, when you are given a table, what would you might do to figure out which equation works with it? I hear plug it in, and that will work. That will work. You can plug the x where the x is and work it out, and hopefully you get the y that goes with it. And then you try it for each point, and you see which equation works. But I have an easier way to do it. How many is up for an easier way? Good. So here we go. Repeat after me. I promised first block that you guys repeated after me like in an amazing way, so do not let me down. Okay? When I say table, you say stacked. Okay? You ready? When I say table, you say stat. So let's practice. Table. Stat. 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 So I told first block, we say table, stat, table, stat. And it got to a point I said, I really want to get in a huddle, and I want to be like, whoo, 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 whoo. Because they're going, table, stat, table, stat, table, stat. So, but, you know, that's going to be like our cheer before we go into the SOL. So when you see a table, listen with me. Okay, when y'all with me on that, like the huddles they do? Table, stat, table, stat. Okay, when you see a table, I want you to think 95% of the time. So there's always that, you know, Ms. Corns, you say to think this, but what about that other percent of time? Like if it's a direct or an inverse variation table, it may not be stacked. But 95% of the time when you see a table and they are asking for the equation, we are going to go to stat. So I want you to press your stat button on your calculator. Everybody see stat? It's right under the delete button next to the arrows. So we're going to go stat, edit, and you can enter, first of all, you need to clear out your list. So arrow up to L2 and hit clear and enter, and then arrow up to L1 and hit clear and enter. You can enter your list in. Now the other day when we did our lists, we just did one list. But because I have X's and Y's, I'm going to use 2 lists. I'm going to put all my X's, so -2, 2, 4, and 0 in list 1. And then I'm going to put -11, 1, 7, -5 in list 2. Any questions on that? Then we're going to go get the equation. Now, in Algebra 1, you know how many equations? 2. Very good. You know, what are the 2 equations you know? So they're either linear or they are quadratic. How do you know a linear? I heard mx plus b, or x is to the first power. You know a quadratic because x is to the second power. Those are the 2 that we are going to use in Algebra 1. It's either linear or it's quadratic. My question is, look at your answer choices. What are we going to want to get here? Linear. X is to the first, so you're going to want to get linear. So we are going to go stat. We're going to go to calc. Instead of 1 variable statistics, we are now going to go down. We're going to go to choice number 4. What do you see with choice number 4? What's ax plus b? It's the same thing as what? Mx plus b. The calculator uses ax plus b. Mx plus b is the same thing. This is a linear equation. What do you think choice 5 is? There's your quadratic. So we want linear. So we're going to press enter, and you might have to press enter a couple different times down to calculate and press enter. Now, mine gives some extra numbers. Yours may, how many have the R values on there? How many don't? So some already have the R values, some don't. That's okay. You don't need the R values. That's for Algebra 2. But it does tell us that A is equal to 3. So what can we do with 3? Plug it in. That's your slope. And B is equal to negative 5. That's your y-intercept. So what would the equation be? Which would be letter choice H. So let's do example 2. I want you to put it in. So we see a table. So what do you say? Stat. Table. Stat. Table. Table. Woo! Okay. So you end up with, if you put your list in, you go to table or stat and then edit and put your list in. Do we want the linear or the quadratic? For 2 reasons. Who can tell me one reason? It says linear line, and all your answer choices are in mx plus b form. So check this out though, this one's slightly different. If it's ax plus b, this one gives you, whoops, not y, it gives you lots of decimals, which means it's a scatter plot, which means the line is not going to be perfect, which means you're going to have to round. So Carson, what does it tell you A is? Negative 0.35. Did yours say 35? No, it's not negative? Thank you. All right, so 3, 4, 6, okay? And B is 303 something. So you'll have to round this off. This rounds to about 0.35, and this rounds to about negative 19.3, and again, you'll have to just choose the one that is closest. So, which answer choice would work? J. 0.35x minus 19.5. All right, try that one. So the question is, why wouldn't H work? Because this is your A, and this goes in front of the X. So it's got to be 0.35x. This is your y-intercept, your B. All right, so you try that one. So this one has purpose. What would the purpose for this one be? Yeah, it's not using x's and y's. It's using c's and n's. So still the same thing. So which answer choice works the best? H. Any questions on that? 2.15x plus 0. So it would be H. Good. All right, you try. All right. So which one is the best option? H. Any questions on plugging it in and getting your linear? So this is in, you know your G's are your X's. And you know, so if this is, like you should get A with 60. So you know if you plug it in normally, it would be 60x plus 50. So that's the one that matches that. If G is X, then you just substitute the correct variable in. Okay? All right. This one has purpose to it. It's all right. So this one has purpose to it. What would the purpose be? The fact, number one, that there's a fraction. Okay, you're going to get a decimal in your calculator. My question to you, does that throw you off to change from a decimal to a fraction? You'll either have to do math inner, or you'll have to convert it appropriately. And then the other thing is the table is sideways and not up and down. My question is, which ones are your X's? Okay, so in this case, how do you read? Normally we read a table from left to right. In this way, how would we read the table? Top to bottom. So your X's is going to be your top row, and your Y's is going to be your bottom row. And someone brought up a good point. Normally we like things in Y equals MX plus B. Look at this. Which letter's Y? P. So this is like your Y's, and these are like your X's. So make sure you get them in the right list appropriately. So try that one. I underlined A just because I was talking about P being Y equals. Any questions on the correct answer choice is A. And you got a negative 0.0 in your calculator. To make sure that the fraction works, you just have to either math enter it, or somebody said, we know that's in the hundreds place, so that makes that 1 over 100. And it's the only one, what? With the 50. Oh, that's true. Gotcha. All right, so let's get to this. So here is more like what you were going to see on your SOL. You may see a couple problems where it's simple table, stat, go get the linear, or go get the quadratic. Okay? First of all, what do we see? We see a table, and you say stat. So that's the first thing I want you to do. I want you to put this into your stat. So do that for me now. All right. The question is, how do I know what to do from here? So, do you see, there's some keywords here. This first sentence, that is in code. Did you know that? You know what it says to me? That says, based on the line of best fit. That says, hey you, go get the linear equation. Because it says, based on the line means linear of best fit, and that means go get the linear equation. Does that make sense? It's code. It doesn't say it at all, but that's what that means. That means go get the linear equation. So go to Stat Calc and go to Line Reg and tell me, let's round it. My question is, we see a lot of decimals here. Where do you think we should round off our decimals? I hear tenth. Can I actually do, would anybody actually think that they might, if this were the SOL test, do the whole number? So a lot of people do. So I just want to show you something, okay? Let's do the whole number. So this would be Y equals, what's A? Negative 19x plus 244. Now, let's answer the question. How many complaints, what's the complaints? Is that X or is that Y? The complaints. So figure out what Y is at the end of week 8. So week 8 is your X's. So if I know X is 8, how can I figure out what Y is? Just plug this in. You could totally do that as well. Just plug this in for X and figure out what Y is. So tell me, what's negative 19 times 8 plus 244? Make sure everybody can get it. We get 92. Huh. That's not one of my answer choices. Okay. So let me talk about this. This is super important. We know it's not A and we know it's not D. But it's kind of, you know, and someone earlier said, it's close enough to 91, just pick 91. But I'm going to tell you on the SOL, they're going to have an answer choice that says 91, and they're going to have an answer choice that says 93, and you're going to get 92. And the question is, eeny, meeny, miny, mo, which one do you pick? So that is a problem. So here's what I'm here to tell you today. Because I agree with Caleb, because we rounded these off really short to the whole number, our answer is not very exact. If you want your answer to be more exact, what do you need to do? You need to know, go gather more decimals. We need to go get more of these. So I want to go back and I want to go get more decimals. And I would say, I would go like 3. Let's go 3 decimal places out. So, Johnny, give me what A would be if I went 3 decimal places out. Y equals, and I'm going to actually go 057. I'm going to go 3 places out, okay? 057x plus, what would the B be, Carson? 3 places out, plus, what do you have, Travis? How about 6, 7? Okay? 8, 6, 7. So now I want you to go back, and I want everybody doing this, okay? Don't just sit there and watch. I want everybody doing this. Now go back and figure out what y is and plug in 8 for x, plus 243.867. 91.411, which is much, much closer now to 91. 91 should be the answer. But do you understand what I'm saying? Like, if you round it off, and it's going to get to a point where it's really complicated, that if you don't go get lots of decimals, your answer will, like, it's going to be in between 2, and you're not going to know which one to pick. So go get lots of decimals right off the bat, and it'll be closer. Okay, it'll be closer to an exact answer. So let's look at this. What do we see? I see table. Stat. All right, so let's do it. Go to table, go to stat, put this table in. Okay, so I want you to read this because this is code right here. It doesn't come out and say it, but when it says, based on the quadratic model, you know what that says to me? It says, hey, you, go get the quadratic equation. Based on the quadratic model, go get the quadratic, and sometimes it might even say curve. Based on the curve of best fit. Are lines curvy? No. If it says based on the line of best fit, that means linear. If it's based on the curve, what shape is a quadratic? It's a parabola. It's a curve. Okay? It's not a parabola, it's a parabola. All right. So go stat, calc. This time we want choice number 5, the quad reg. Okay? So the equation says this. Y equals ax squared plus bx plus c. Well, that's not a big deal because, I mean, how many recognize ax squared plus bx plus c? When we did our quadratic formula, what was a? A was the number that was in front of the x squared. B was the number that's in front of the x, and c was the number that's by itself. That is the basic form of a quadratic equation. So if we go, yes, sir. Okay, so we are going to go get lots of decimals right off the bat. We're not going to waste our time with doing it and then having to go back and redo it. So go get lots of decimals. So y equals, what would my equation be? Whoops. Well, I need to plug numbers in for A, B, and C. So negative 16.429 if you round, x squared, then what? Plus 1.071x plus 199.6 643. Good. Okay, so there's your equation. The question says, what is the height? So which one's the height? Is that your x or is that your y? Your height is y. So what's the height at 3 seconds? 3 seconds is your x. So the question is where do I put 3 in at? This is your x. It's your x. So, but the question is, I got 2 x's. All right, so negative 16.429 times 3 squared plus 1.071 times 3 plus 199.643. Tell me what y would be equal to. Did you get it the second time? So 54.995. That's pretty darn close. Do you see why were we able to get it so close to 55? Because we took more decimals. Had we not taken decimals, I'd be curious, like if you rounded to the whole numbers, what it would be and how far off would it be. So it'd probably be right in between those, and which one do you pick? But because we took more decimals, it would be the other way. Any questions on that? Any questions on how I knew to get the quadratic? Okay. So this is our last example for this part. Do I still see a table? It's a sideways table. So you got to make your own table. Which ones go in list 1? The X's. Very good. The first numbers you see. And then which one goes in the second part? The second numbers. The Y's. All right. Go for it. Put it in. I want you to take a minute. I'm going to pause the recording, and I want you to take a minute. And first of all, which one do I need to check? Do I need to get the linear or the quadratic? How do I know? It doesn't tell me. How do I know which one to go get? Why try both? Look what are A and B? Those are quads. You need to check the quad. What's C and D? You need to check the linear. So check both, and I want you to tell me which one works. So we are stumped at this point in time because when we put in the quad, we see that B works. So we know A is out. Whoops. We know A is out. When we put in the linear, we see that C works. So we know D is out. So it's either B or C. So here's what I would like for you to tell me. I want you to think for a minute. Remember how I said, like, when I grow up, I want to be that cool chick off of NCIS that's brilliant? Yeah, they put all the stuff on her table, and she figures it out, right? So I'm placing on your table those points. I want you to explain to me how to do it and how you know which one your answer is and why it is that way. Okay? So we figured out that if I place a bunch of points in your lap, what can you do with points? You can plot them. And we know that linears make the shape of a line. We know quadratics make the shape of a U or an N. So if I plotted this, check this out, if I plotted this, all right, -4, -4.8, where do I go? Up 4, down 4. Ish. And it doesn't have to be exact. Okay, we're just looking at a general shape. -3, -8.2. So left 3, down about 8.2. -2, -9.1. Where am I going? Over 2 and down 9.1. -1, -8.1. 0, down 4 point something. 1.3. And if I connected this from left to right, it would make a U. Okay? The other thing, hold that thought one more second. The other thing, does everybody have this in their stat? Do you still have these points in your stat? Okay, let me show you something in your calculator that your calculator can plot it. Do you still got yours?
No.
Okay, so we're going to go to y equals, and I want you to arrow up to where it says plot 1, and it's blinking, plot 1. And I want you to hit enter. So I want you to highlight the plot 1. Everybody with me? And then I want you to hit graph. That, you must not have highlighted it. Okay? So, any questions? I will try to come up with more examples for Candy. Right, you can totally, like if you understand how to plot these, that you're saying, okay, we're going, starting here at 4.8, then we're going down, then we're going down, then we're coming back up. Like you're just graphing in your head. But it's all about plotting it. So here's my next thing. On the day of the SOL, I'm going to look at you and I'm going to say, table, 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 table. And then I'm going to look at you and I'm going to say, graph it out, graph it out, graph it out, graph it out. Draw a picture. It makes so much more sense. Okay? We're going to have a whole cheerleading thing. All right. So, any questions about plugging in your tables and getting the equations of best fit? What about making predictions? And like, you go get the equation and then you plug in for x and solve for y. Okay. So, what we're going to do is we're going to do a little switch gears, and we're going to go to cube roots. So, you can totally write this down on the same piece of paper just so you can have it in a set of notes. But we're just going to switch gears. And I explained to you the other day that if we take the square root of 9, I am asking you what number squared is 9? And you would tell me 3. So the square root of 9 would be 3. And we learned the other day that the cube root of 64, what number 3 times what times what times what? 3 times would be 64. Would be 4. 4 times 4 is 16, and 16 times 4 is, so the cube root of 64 is 4. Okay? What we're going to do today is we're going to actually simplify the cube roots. So the first thing that we are going to do for a warm-up is I would like for you to refresh your memory how to simplify. If I ask you to simplify the square root of 108, I want you to take a minute and simplify the square root of 108. Okay. So just as a reminder, here's our list. How many wrote their list really quickly? 1, 4, 9, 16, 64. All right, I think that's all we need for this. Now the question is, anybody simplify theirs into like 3 times square root of 12? Don't leave 12s. Don't leave square roots of 8, 12, and 20. I love that y'all remember that. 8, 12, and 20, because those are like the number one mistakes, because we know 8 and 12 and 20 can go further. So do I start dividing by 4 and 9? No. Okay, I guarantee right now, I'm going to send a shout out to Gavin and Caleb. They are fishing in a tournament. I guarantee you they are not out there going, let's catch the smallest fish today. Because that's not going to win them their tournament. They're out there and they're trying to catch the biggest. So that's what we got to do. We got to go catch the biggest. Somebody told us once upon a time to take it first and do what with it? Half it. And so we're going to start with 49. Does that work? Does 49 work? Then I go to 36. So that goes down into 36 times 3. 36 is perfect. So it becomes 6 times the square root of 3. So how can you check yourself? What do you mean? Well, you could totally put 6 back in, and he goes back in as a 36, and you make sure, and you work backwards. Or, Amber, what could you do? What do you mean? You put in the square root of 108. You put in 6 times the square root of 3, and you hope that you get the same irrational decimal. Okay? Make sure you get the same answer. So, let's use, to do this, we use our perfect squares list. So in order to do cube roots, we're going to have to use our perfect cube list. So we have 1 cubed, 1, 2 cubed, 8, 2 times 2 times 2, 3 cubed, 27, 4 cubed, 5 cubed, 125, 6 cubed, 6 to the third power, 216, 7 cubed, 343, 8 cubed, 512, 9 cubed, 729, and 10 cubed, 1,000. All right, so you might want to even write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, yeah, because that's your list. When I tell you to begin on your SOL, we don't click to the first question, right? We stop and we make a list. On that list, one thing that you should write is your perfect squares. The second thing you should write is your perfect cubes. Okay, are there more perfect cubes? But this gets you all the way up to 1,000, so this is going to be a good start. So we're going to look at the first one on here. We are going to simplify the cube root of 72. So what I'm going to ask you to do is I want you to find a number off of that list that can go into 72. And you want to try to choose a big one if you can. Well, I'm not asking you to take the cube root of it. I'm going to show you that in a minute. I just want you to take 72 and figure out 72 divided by 64. No. 72 divided by 27. No. 72 divided by 8. Yes. The cube root of 8 times 9. Silly people then would circle what? They'd circle 9 because it's a perfect square. But we're talking about cubes. 8 is the perfect cube. When 8 comes out, he comes out as a 2. The cube root of 8 is 2. And then we do the cube root of 9. Let me show you how to do this in your calculator. I want you to locate the button. We're going to put both of those in. We're going to put in the cube root of 72, and then we are going to put in 2 times cube root of 9 and make sure that they are the same number. So, locate the button Math. Go to Math. Do you see your cube root button? Math what? 4. So go Math 4 and put in 72. And then I want you to put in 2 times the cube root of 9. And make sure you get the same decimal. Any questions on that? Do you need to see another one? Nope. Okay, so I want you to try the rest on this page. And while you guys are trying that, I'm going to go through the calculator on the board. So I go to Math. I go down to choice 4. It is the cube root of 72. and I press enter, and I get that decimal, 4.160167, something like that. Then I'm going to put in my answer that I got, and I want you to put in 2 times math 4, the cube root of 9, and make sure I get the same decimal. That's how you know you would have done it correctly. Okay, any questions on that? All right, so take a minute and work on those problems, and then we'll check them. So we're going to switch gears, and we're going to go to box and whiskers. Again, I'm going to do one by hand, and I want you to put that in the bottom, in the blank section. I did that on purpose. So all a box and whiskers plot does, it displays, it's a way to display the data. So instead of doing like a bar graph, instead of doing a circle graph, it's just a different way to display the data. And all it does is it takes data and splits it into 4 equal sections. It splits data into 4 equal sections. So the easiest thing that I could explain this to you and do this with is test grades. So I need some test grades. Give me some test grades. 95, 84, 99, 70, 76, 81. One, two, three, 4, 5. Give me one more. All right, 54. All right, so all we're going to do, and this is important, all we're going to do is display the data in an organized way on a number line. When you come in the next day and you want to know about test grades, let's say we took a test yesterday, what's your first question to me when we come back in? You want to know the average, you want to know. So, yes, you'll need to write this down on your blank spot, okay? You want to know the average. You also want to know who made the highest and who made the lowest. Okay, well, a box and whiskers will tell you that, okay? So, there are 5 points that you want to plot when you do a box and whiskers, okay? The very first thing that you want to do, though, when I give you a list of data, is you want to put it in order, numerical order from least to greatest. That's the first thing that needs to happen. So help me put it in order. 54, 65, 81, 84, 95, 99, and 100. All right, that's the first thing. So what we're going to do, the first thing you want is your lowest value. Is that useful information? Yeah, it tells you, you know, where you stand. If you know, like, who made the highest and who made the lowest, it gives you an idea of where you are at based on your test score. So our lowest is 54, and our highest is 100. So that's what we're going to, 54 to 100. Okay? So I want you to look at my meter stick. Another thing, besides displaying the data, that a box and whisker plot will do is it will divide the data into 4 equal parts. So I want to take this out to the wood shop, and I want them to cut it into 4 equal parts. After I measure the 2 ends, the highest and the lowest, where would be the first cut? What would be the next thing? We would get the middle. What do we call the middle in algebra? Not the average, the median. The median is the middle. So if I counted to the middle, what would be in the middle? 81. Okay? What if I had 2 in the middle? Add them up, divide by 2. You get the average of them if you had 2 in the middle. Okay, so let's say I've taken this stick to the wood shop and we've made 1 cut right here. I got 2 pieces. How am I going to get 4 pieces from that? What do I do? So I'm going to go get the median of the lower half and the median of the upper half. So we call this the lower quartile and the upper quartile. Okay? The question is, do I include the 81 or not? So I imagine this, when you have 1 in the middle, it's like PE, and you choose 2 captains. This person takes this person, they take that person. They take this person, they take that person. When you get down to 1 left over, now I know now, most of the time they just give 1 team an extra person. But what if it had to be equal? Like it had to be a certain amount of people on the court. So what do you do with the 1 person? They sit out. They were not included in finding the medians of the lower. Okay? So you're going to find the medians here. Now what if I had 2 in the middle? Would it be fair to put 1 with the other end and 1 with this side? If you had 2 in the middle? Like if I had 2 numbers in the middle, could I evenly include this one with the lower half and this one with the upper half? Would that be fair? Yes. So if there's 2 in the middle, the median's included. But if there's only 1 in the middle, the median has to sit out because it wouldn't be fair to give 81 to either piece. So he just doesn't, he's not in it, okay? So the median of here, I have 2 in the middle. So what do I do with those 2? Add them up, divide by 2. So 65 plus 75 divided by 2 is 70. Okay? On this side, 95, 99. The middle is 97. You find the average. So those are your 5 points. So then we plot them. If I want to go from 54 to 100, what do I want to count by? How many marks do I want on a number line? We've talked about this before. Somewhere between, we don't want a number line that looks like this. That's too many marks. So I'm going all the way from 50 to 100. I would count by 10s or I would count by 5s. I heard someone say 2. If you started at 50 and you counted by 2s, that's like 20-some marks on your number line. That's too many. So 50, 60, 70, 80, 90, 100. You want somewhere between 5 and 10 marks. So we're going to plot our points. I'm going to plot 54. I'm going to plot 100. I'm going to plot 81, 70, and 97. The middle 3 points are our box, and the outskirts are our whiskers. All that is done is you need to know what each point stands for. You need to know that this is your lowest value, this is your lower quartile, this is your median, this is your upper quartile, and this is your highest value or highest extreme. We're going to talk more on Monday, but they could ask you all kinds of questions. One question could be, what's the range? How do you find the range? High minus low. What's the interquartile range? Where's your quartiles? Here's a quartile, and here's a quartile. So how would I find the range of that? You would do high minus low of that. So you need to know that word, interquartile range. We're also going to talk about a couple more things, but we will get to that on Monday. Okay? Any questions? Do you know the percent of data within each piece? If each piece is equally a fourth, each piece is worth 25%. Which means if I had, let's say I had 25 whole number or 20 numbers in the whole thing, how many would be in the first piece? 5, 5, 5, and 5. And we're going to talk more about those percentages on Monday as well. All right.